All right, let's take a look at another word problem. Create an application named Photo Demo that demonstrates three related classes. So we did two related classes. Now we're going to, of course, do three. For a company that develops photographs, create a class named Photo that includes fields. Okay, so that's not property, that's instance fields for width and height, and properties for each field. So let's just kind of start with that sentence right there. A class named Photo. So here's my photo demo. Let's create a class called Photo with fields for width and height. Private fields. Let's just go with whole numbers. Width and height. And properties for each field. These are not auto-implemented properties, but Visual Studio catches my drift. And this is scary good. It never used to do this. I don't know, does this work that well for you guys? Yeah. Sometimes yes, sometimes no.
Sometimes no.
It never used to do this. This is scary. But it's also not that big of a deal. I guess the main thing is that you have to understand what's going on here. That we're accessing the fields. So these are our instance fields. And these are our get and set properties, or better worded is read write for the fields. Include a protected price field. Ooh, that's new. And set it to $3.99 for an 8-inch by 10, $5.99, and $9.99 for any other size. So we have a price field that's marked as protected and set it. And notice the price field requires a get accessor but no set accessor. Okay. So no set block. So first things first, protected decimal called price. That's a new one, right? So here's the thing about private. Private basically means this class only. So at a high level, private access modifier scopes the member to class only. Public access modifier scopes the member to the entire project. So basically, any other files in the project can access public members. Protected is in between. Protected access modifier scopes the member to both the class and inherited classes. Okay, so the scope is more open than private because private is only the current class. Protected is both the current class and inherited classes, and then public is pretty much wide open. Okay, so protected is in between private and public as far as its access is concerned. So now we've got a protected decimal price. When I construct a public photo, whenever I construct a photo, I've got some conditions. It's like if the width is one thing, if the width is 8 and the height is 10, then it's $3.99. If the width is 8 and height is 10, then the underscore price is $3.99. Else if the width is 10 by 12, 10, and height is 12, then the price is $5.99. Else, price is $9.99. So whenever you construct a photo using the default constructor, it will read the width, it will read the height. Let's set it up so that you have to construct a photo, passing it a width and a height. So I'll say int width, comma, int height. So we'll parameterize our constructor and say, okay, let's set the width equal to the width, and let's set the height equal to the height. So whenever you construct a photo, you must use the constructor here. We don't have auto implemented properties, so we're not going to be using that object initializer. We will be using the constructor, and that will set the width, the height, and the price. The price field requires a get, but no set. And so we can just write a property that is a read-only property for price, public decimal, come on man, type price, and then return price. So notice there's no set block here. It's being set on the constructor, and then we can access it via a read-only property. The price field requires a get, blah, blah, blah. Also include a toString that returns a string constructed from the get type and the value of the fields. So here's our toString method. Public override toString. I don't need base toString here. I'll say the photo get type. Get type is going to be, again, the project photo demo.photo, but that's what the requirement says. It says call get type. The get type, so that'll say the photo has a width of, or has dimensions of, we can call the get block of the width by height, and a price of price colon C, formatted as currency. So that's our toString, and that fills that in. Derive two subclasses, matted and framed. So I can either demo this, or just continue on. I'll just continue on before I do the demo. Matted photo. The matted includes a string to hold the color. So there's one extra field on matted. The framed includes two strings that holds the material and a style. So matted photo. Then it says the price of matted photo increased by $10 over its base cost, and the price for a framed photo increases by $25 over the base cost. Ooh, cool. Each subclass should include a toString. Okay. So let's go ahead and start with matted photo. So a matted photo is a photos, again, is a relationship, aka inheritance. Matted photo. Public class matted photo is a photo. Again, this is the how to implement inheritance. I need to make sure that photo is marked as public class photo? It is. What are you barking at me? Okay, now this is really good because my parent has a constructor that takes two integers in, so the child has to have a constructor. This is really something to zone into, guys. Since my parent has a constructor, there's only one way to construct a photo. Therefore, a child is going to require those fields on a constructor. And so let's make this constructor. Now, what is the field? Has a color. So I'll make a prop tab string color. And let's go ahead and make my constructor public matted photo. Again, my parent has a parameterized constructor, therefore my child must also have a parameterized constructor that takes two ints. So I'll say int width, comma, int height, comma, string color. What you want to do with the width and the height is you pass them up to the parent constructor, right? You're going to take this width and height. Where do width and height exist? They exist in photo. So we need to take these values that are passed into the matted photo constructor and pass them up to the parent. You do that with this syntax right here. You do colon base width comma height. Now again, that's the constructor of my parent. Base refers to the parent constructor, because this is the child constructor. So in coming to this constructor, we take a width and a height, we pass those values up to the base, and we also set the color. Of course, we'll set the color property equal to the color parameter. So that calls the set block here of the color. And now my error goes away because my parent has a constructor, aka your child is going to be forced to be given that information to the parent. So that's how we do that. So here's the rule kind of that I said that you had to kind of pick up on. When a parent class has a constructor, a parameterized constructor, the child class must also have a parameterized constructor to pass those values up to the parent, right? And again, you'll notice if I take out this constructor, you can kind of read, it says there's no argument given that corresponds to the parameter width of photo.photo. Well, that's the photo class photo constructor. And so it's basically not happy that I'm not giving it the data that it needs, which is a width and a height. Let's override toString public, override toString. Now I am going to use the base toString. Get type has dimensions of width, height, and price. And I'll also say, and a color of color. So again, the base toString plus the color. Again, you got to make this not be a giant run-on sentence. This will say the matted photo has dimensions of this and a price of that and a color of that. So if this was your English class, you might be docked for a run-on sentence, but let's just demonstrate a photo and a matted photo. Toolbox, button. photo, my photo equals new photo. And now it says width, we'll just say 8 by 10 because I think that was one of those specific dimensions. Okay, so this is using the constructor to set the width and the height. Keep in mind there's also a price. And let's put the data out in the toString, label results. Okay, label results text equals my photo toString. Okay, and an 8 by 10 photo should have a price, if I did this right, of $3.99. And let's run the right project. Okay, create the photo. The photo demo photo has dimensions of 8 by 10s and a price of $3.99. So the photo is working. Pretty straightforward there. Let's create a matted photo. I will copy, paste this button, create a matted photo. This will be called button matted. And we'll say matted photo, my matted photo equals new matted photo. Now notice there's three, right? There's a width and a height and a color. Oh, by the way, I forgot to modify its price. Let's do 8 by 10 because we know that's $3.99, and a string color of, black. Okay, what I forgot to do was this piece right here. The price for a matted photo is increased by $10 over its base cost. So, remember that we marked price as protected. That means that children have access to this field. So one thought, well, you'll notice as I come down into my constructor, I do have underscore price. I do have access to this field equals base price plus $10. So again, anytime you see base, it's going up to the parent, getting the price. That might work, that might not work. Let's check it out. I wanted to take the base price, which should be $3.99 plus 10. I think this is going to work, but now let me go back into, I don't think I finished this out. Yeah, I know. Stop. I don't think I finished coding this. Come on, Visual Studio. Let me close everything down. Close all tabs. And go back into here. Here's what I didn't finish. Label results.text equals my matted photo toString. Now the 8 by 10 should be $3.99. If my addition worked plus base price equals base price by 10. Again, I'm kind of skeptical if that's going to work. Let's see. Okay, it worked. Base price did get the $3.99, and we added in 10. There's other ways of coding that, but this is nice and efficient of saying, hey, you already have a base price as calculated when you called this constructor. The price already had a value when you passed it a width and a height. So then just update that price by $10, and that got it to work. So the matted photo has 8x10 and $13 and a color of black. There's our nice run-on sentence that we were calling for. And if you kind of understood everything for matted photo, then you're going to understand the other class, but it doesn't hurt to do it again. So that was matted photo. There's also a framed photo that has 2 string fields that's material and style. So let's create another class. Add a class, framed photo. Framed photo is public. It inherits from the same parent of photo. It has 2 additional properties, string, material, and style. Okay. Now let's make the compiler happy. Let's make a constructor, framed photo, that takes in a width, a height, a material, and a style, and pass the width and the height up to the parent. And we'll set the material property equal to matte and the style property equal to style. And again, we'll set the underscore price because it's protected. We can directly access it. The price equals the base price, base dot underscore price plus 25. So you get to introduce to this base keyword once you start dealing with inheritance. You've seen base called many times, and base typically just refers to the parent. So get the parent's price, which was set right here, and add 25 to it. And now my toString public override toString. Return base toString plus a material of again, you'd have to figure out how to actually make sense in English. I hate my broken run-on sentences, but now when I create my framed photo, we set the material, we set the style, we set the width and the height, and we update the price. And then toString. So now if I kind of come back here, copy, paste, create a framed photo. Oh, I didn't name it. Let's undo and name my button framed photo. Okay, I take a width, a height, a material, and a style. Again, we'll just go with the 8x10 because we know what the math is there. A framed photo material. I don't know, matte. Is that a material for my Sure, let's just go with matte. And what's the last one? Style. Modern. A matte, modern framed photo. My framed photo to string. The framed photo has 8 by 10 is $28.99. The material of matte and a style of modern. You guys getting the swing of it? Couple head nods, yes. So, sir.
So is there a way to not have to include the 8 and the 10 for every constructor? Is there a way to inherit the values as well?
Is there a way to not include the 8 by 10 for every constructor? So what are the other options, in other words? So if you don't want, so what you could do, right, is you could overload your constructor with public photo. You could do that. And then if you have this, right, and we comment this out, there you go. And you can just use the other ways of setting the data. Does that answer your question?
So is there a way to also inherit the values as well? So say you make a photo class, right?
Yep.
Have 8 and 10.
Yep.
And then inside of the matted photo class, you just include the color, and it also includes the 8 and 10 values.
Okay, so let's kind of bring this in. We'll take that out. Okay, so we're bringing in the 8 by 10 here, and in matted photo, if I take this out, for example, if I take this out, it says there's no argument that corresponds to the width of basically the parent class constructor. I believe it's a hard rule that when you have a parent constructor that takes parameters, that you have to provide that data from the child, so your child needs a constructor with those parameters. I believe that's a hard rule. I'm trying to think with these properties if there's a way to get around it. And so like maybe public matted photo, and here's our as such, if you are going to assume an 8 by 10, but you have to appease the compiler, you have to ultimately pass something up. I don't know if that answers your question. Great.
So like say if you want to make it more flexible, instead of 8 by 10, you would do the base of it dot width pretty much.
Yeah, I mean you could do sure.
In the constructor, like in the CS file itself with the form. So like say you just want to make it more flexible, instead of the 8 and 10, you just do the photo original dot width, comma, photo original dot height, instead of having to do 8 by 10 hard coding it.
So let me you want me to try and code that out?
No.
You're good?
Yeah, I'm good.
Okay.
You answered.
Okay. Great. Okay, so that kind of solves problem number 2. I think we'll stop the recording there.